Welcome back. In the previous session, we have discussed about the physical properties of metals and non-metals. We also saw how does a metal react with the non-metal, and which in turn leads to the formation of ionic compounds. Let us look at some other chemical reactions of metals and non-metals to understand a little more about their chemical nature. Let's begin with the reaction of metal with oxygen. How does a metal react with oxygen? So you would have seen this experiment where we take magnesium ribbon and we burn it in the presence of oxygen. It will burn brightly and finally you get a white colored ash, which is magnesium oxide. Similarly, if you take copper and heat it, after some time you get a black colored coating that is formed on the surface of copper metal. So this is magnesium oxide and this is copper oxide. So a reaction between metal and oxygen will result in the formation of metal oxide. And you already know that metal oxides are basic in nature. If aluminium is heated in the presence of oxygen, we get aluminium oxide. So metals react with oxygen to give you metal oxides, which are basic in nature. But there are some metal oxides which have both acidic as well as basic properties. For example, aluminium oxide, zinc oxide, which can react both with an acid and with base. For example, aluminium oxide, if you take and make it react with an acid, hydrochloric acid, we get aluminium chloride plus water. Aluminium oxide will also react with base to give you sodium aluminate plus water. Such metallic oxides like aluminium oxide and zinc oxide, which react with both acid and base, are known as amphoteric oxides. Amphi means both. So this react with both acid and base. They have both basic properties as well as acidic properties. Similarly, you can write the equation for zinc oxide reacting with hydrochloric acid and zinc oxide reacting with the base. Now, if we observe carefully, not all metals react similarly with oxygen. Some metals are highly reactive with oxygen, whereas some do not react at all. For instance, sodium and potassium metals are highly reactive. If you keep these metals outside, they react with oxygen readily and they may even catch fire. That is why we store sodium and potassium metal under oil, kerosene oil, so that there is no contact with oxygen and the reaction is cut off. So metals like sodium and potassium are highly reactive. Magnesium, it is mildly reactive. It does show reaction magnesium, copper, aluminium, zinc, all these metals, they are mildly reactive with oxygen, and on reacting with oxygen they form a thin coating of oxide on their surface. So if you have seen magnesium ribbon, on the surface of the magnesium ribbon we find a black or greyish coating. So that is nothing but magnesium reacting with the atmospheric oxygen and forming a oxide layer. This layer of oxide, it acts like a protective cover, protective layer, and hence this protective coating will prevent further oxidation. Thus the metal is protected from further corrosion. So this acts as protective covering. Whereas other metals such as silver and gold and lead, they do not react with oxygen at all. Not reactive at all. So we can see very clearly that some metals react with oxygen and other metals do not react with oxygen. Talking about those metals that react with oxygen, providing metal oxides, most metal oxides are insoluble in water. Whereas there are some metal oxides which are soluble in water, for example sodium oxide, potassium oxide. If we dissolve these metal oxides in water, we get metal hydroxides which are called as alkalis. So the metal oxides which are soluble in water produce metal hydroxides which are called as alkalis, whereas other metal oxides are not completely soluble in water, and we know that alkalis are bases, hence it shows that metal oxides are basic in nature. This is the first type of chemical reaction of metal with oxygen, where different metals show different levels of chemical reactivity. Let us move on to see how does a metal react with water. Like oxygen, even metals do not react with water in the same way. So for example, metals like sodium, potassium, lithium are highly reactive with water. So when we put sodium metal and potassium metal in water, these reactions are spontaneous and large amount of hydrogen gas is produced, and these are highly exothermic reactions. So the heat produced is so much that this will combine with hydrogen gas and it may even catch fire. Explosion can take place. So sodium and potassium are highly reactive with water, and these metal oxides then they dissolve in water to give you metal hydroxides, which are basic in nature, which are alkalis, which already we saw. So metal plus water will give metal oxide plus hydrogen gas. This metal oxide will dissolve in water. Metal oxide will react or dissolve in water to give you metal hydroxide. So the reaction of potassium and sodium is very reactive, highly vigorous and highly exothermic in reaction. So this potassium and sodium, they can react even with cold water. They are very reactive with water. Compare that with calcium. Calcium also reacts with cold water, but it is not as vigorous as potassium and sodium. So the hydrogen gas does not catch fire. Instead, the hydrogen gas, they attach to the surface of calcium. The hydrogen bubbles, they attach to the surface of calcium. Therefore, the calcium will float on water. So here the calcium will float on water and there is no fire that is seen. So that is another level of reactivity. So not vigorous, but it is reactive with cold water. On the other hand, magnesium metal does not react with cold water. Instead it reacts with hot water, and as in the case of calcium, the bubbles formed, hydrogen bubbles, will attach to the surface of magnesium and the metal will start floating on water. So magnesium requires hot water for reacting. If you take the case of aluminium and iron, aluminium and iron, they do not react with hot water, instead they react with steam. So water in the form of steam. Producing aluminium oxide plus hydrogen and iron oxide plus hydrogen. So there is aluminium oxide and this is Fe3O4, called as magnetic oxide of iron. Magnetic oxide of iron. It is not to be confused with Fe2O3, iron oxide. And all these they are not completely soluble in water. So these form bases, but they are not completely soluble because they are not very reactive. And other metals like lead, silver and gold, they do not react with water at all. They don't react with cold water, hot water or steam. No reaction. So like in the case of oxygen, different metals show different types of chemical reactivity with water. Some react with cold water vigorously. Calcium reacts with cold water but not so vigorously. Magnesium reacts with only hot water. Aluminium and iron react with steam only, and silver, gold do not show reaction even with steam. So we can see that from the discussion till now, potassium and sodium are reactive, calcium and magnesium come below, aluminium and iron come next, and the least reactive ones will fall in the lower part. Let us now see the reaction between metals and acids. How does a metal react with an acid? We have already seen in the lesson acids, bases and salts, reaction between an acid and a metal. So we already know the answer, that a metal will react with an acid to produce hydrogen and salt. But as we saw in the previous two cases, all metals do not show equal reactivity with acids. Some metals are more reactive, whereas some other metals are less reactive. So with the help of a simple activity, we can find out the reactivities of different metals with acid. For this case, we take hydrochloric acid and in different test tubes, say test tube 1, 2, 3 containing hydrochloric acid, and we put different metals in them. So in one we can put aluminium, another we can put magnesium, iron, copper and zinc. And to measure the rate of reaction, we can put a thermometer in each of the test tube, because this reaction is exothermic reaction. By measuring the temperature in each test tube, we can tell which one is more reactive. Also, by looking at the amount of bubbles formed, the test tube where bubbles are formed quickly and rapidly and in more number will be most reactive, where the hydrogen bubbles are less and formed slowly will be less reactive. And we can also check the temperature in the thermometer. So at the end of this activity, we can conclude that each metal reacts differently with acid. So at the end of this activity, we can conclude that magnesium test tube, the temperature measured is very high and bubbles formed are also more in number. So magnesium is more reactive than aluminium. Aluminium is more reactive than zinc. Zinc is more reactive than iron, and iron is more reactive than copper. So this is what we understand from this particular reaction. Let us write two reactions quickly. So magnesium plus acid will give you salt, MgCl2 plus hydrogen gas. Similarly, zinc plus HCl will give you ZnCl2 plus H2, Al, Fe, give you aluminium chloride plus hydrogen, and this will give you ferric chloride plus hydrogen. Whereas in the case of copper, there is no reaction at all. Copper does not show any formation of bubbles in the test tube, nor there is a increase in temperature in the thermometer. So copper does not show any reaction with acid at all, because maybe copper is less reactive than hydrogen itself. So copper does not show any reaction. So this would be the order in decreasing reactivity. Magnesium is more reactive than all of this: aluminium, zinc, iron and copper. And there are other metals, like for example silver and gold, which do not show any reaction at all with acids. Potassium and sodium should not be used for this experiment, because potassium and sodium, as you know, it is reactive even with cold water. So if you make them react with acids, there will be an explosion. So we do not use potassium and sodium. It is taken for granted that potassium and sodium are highly reactive. So we are beginning to see a pattern in the chemical reactivity of different metals, potassium and sodium being more reactive, followed by magnesium, aluminium, zinc, iron, copper, etc. Also, another important point to note here is that metals do not show any reactivity with nitric acid. When metals are used to react with nitric acid, hydrogen gas is not produced. With nitric acid, hydrogen gas is not produced. This is because nitric acid is a strong oxidizing agent. What happens is, let us say we have aluminium. So when we put aluminium into nitric acid, the hydrogen gas that is produced is immediately converted into water because of the oxidizing nature of nitric acid, and the nitrogen it itself is converted into one of the oxides, maybe nitrous oxide, nitrogen dioxide, or nitrogen monoxide. So hydrogen gas is not produced when metals are reacting with nitric acid, because nitric acid is a strong oxidizing agent. But exceptional cases, magnesium and manganese, they show reaction with dilute nitric acid. So with dilute nitric acid, the two metals magnesium and manganese, they show reaction, hydrogen gas is produced. So that is about reaction between metal and acid, and we are beginning to form a pattern of reactivity. Next, we can see what happens when metal reacts with a metal solution. We can conduct a simple activity to understand this. Say, take a test tube which contains copper sulfate solution. So copper sulfate solution is made, which is blue in color. So to this metal solution of B, so that is copper sulfate, to this we, let us say we add a iron nail. So metal A is iron, and leave this setup as such for some time. After some time, we observe that the blue color will start disappearing, and after one point of time the blue color is completely disappeared, and instead we see a green colored solution in the test tube. This is because iron, being more reactive than copper, will displace copper from its solution, and it produces ferrous sulfate, and copper is seen at the bottom of the test tube as a sediment. So CuSO4 will turn into FeSO4, and reddish brown deposits can be seen at the bottom. This is nothing but our displacement reactions, about which we have already studied in lesson number 1. Displacement reaction is where a more reactive element will displace a less reactive element from its solution. So like this, if we take the different metals and make them react with metal solutions of different metals and look at their reactivity, we can find out which metals are more reactive and which metals are less reactive. Just to give you an example, let us say another example. Say we have zinc, and if you add zinc to ferrous sulfate, we get a clear transparent solution, zinc sulfate. and iron is present at the bottom. So by this displacement reactions of metals with metal solutions, we can find out the reactivities of different metals. So using all these reactions that we have studied till now, reaction of metals with oxygen, with water, with acid and with metal solutions, we can form what is called as the reactivity series. This reactivity series is very important. The reactivity series is nothing but arrangement of metals in the decreasing order of reactivity. And how is this order formed? By all the chemical reactions that we have done till now. So when metals are arranged in the decreasing order of reactivity, we get a reactivity series. So according to the reactions we have carried out so far, potassium is the most reactive metal, followed by sodium, then by calcium, because calcium can react with cold water also, followed by magnesium, aluminium, zinc, iron, lead, hydrogen, then we have copper, mercury, silver and gold. So hydrogen is highlighted here because this tells us that all the metals below hydrogen, they do not show any reaction with acid. These are not able to displace hydrogen from an acid. That is why we saw when copper was made to react with hydrochloric acid, hydrogen gas was not formed because hydrogen is placed above copper. So from this reactivity series, what we understand is this is the decreasing order of reactivity. The metal that is at the top is a highly reactive metal and it is able to displace the metal below it. For example, say aluminium and zinc. So if you put aluminium into a solution of zinc sulfate and zinc into a solution of aluminium sulfate, by looking at the reactivity series, it is very clear that aluminium is placed above zinc, which means aluminium is more reactive than zinc. So aluminium will be able to displace zinc sulfate and aluminium sulfate is formed, whereas on the other hand, if we add zinc into aluminium sulfate, there is no chemical reaction that is taking place. Same is the case with iron. If we add iron into aluminium sulfate, there is no reaction. So this reactivity series will be very helpful in deciding the displacement reactions. The one that is placed above is able to displace the one that is placed below, and this is in the decreasing order of reactivity, where copper, silver, mercury, silver and gold are the least reactive metals. We already saw that silver, gold, copper, they do not show any reaction with acids. Silver and gold don't show any reaction with oxygen, water also. So potassium is the most reactive one and gold is the least reactive one. This is not the complete reactivity series. Very important point to keep in mind. Only those metals which are of concern to us in class 10th have been included in this reactivity series. the reactivity series is in fact huge. It contains many more elements between these also. So this is only a representative series for class 10th only. So that is about the reactivity series and the different chemical reactions shown by different metals. Thank you.